Good morning, everyone, and welcome. My name is Nadine Teles. I'm from F6S, which is one of the partners of the MSec project, and I will be your host for today. So welcome to our final joint webinar between the MSec and the Fed4IoT projects, entitled Advanced Technologies for Hyperconnected Societies, where the idea is to present the main goals, achievements, and results of these projects and learn from them for the future. So without further ado, I just have some technical recommendations before we kickstart this final joint webinar. So please make sure that you have your microphone and your video turned off during the presentation of our speakers. For our speakers, please feel free to turn on your camera and your microphone while you are presenting. And just to make sure that everyone is aware, this is a public event. It is being recorded and will be publicly disseminated. This is the agenda for today's webinar. So apart from my welcoming and technical details, there will be some opening remarks from the European coordinator of MSec and the Japanese coordinator of Fed4IoT. Then we have a couple of slots dedicated to the MSec project, so the main goals, the results, the implementation of our 5 use cases, and then the feedback from 2 cities that have worked with us over the past 3 years, Santander and Fujisawa. And then we will give the floor to our colleagues from Fed4IoT for also presenting their goals, results, and the 4 use cases they have been working on over the duration of their project. And then we will close the session with some closing remarks from our Japanese MSec coordinator and from the European coordinator of Fed4IoT. So once again, welcome everyone. Hope you enjoyed this session and you learned from the main takeaways of both our projects. I will now give the floor to Vanessa Clemente Nunes, which is the MSec coordinator from the European side from Worldline.
Thank you, Nadine. So welcome everybody. Thank you very much for your participation. It's also a pleasure to be with our twin project Fed4IoT to present all the results that we have been worked during the last 3 years of both projects. So I hope you like it and you enjoy, and you can get also more information always in our websites, and you will find all the deliverables and scientific publications and so on if you are more interested to get more insights about both projects. So thank you.
Thank you so much, Vanessa. And now also with some welcoming words, I give the floor to Idenori Nakazato from Waseda University and the Japanese coordinator of Fed4IoT.
Okay, so I'm Andrea Ritti, probably.
Oh, sorry. Okay. I forgot to turn on. So thank you very much, Nadine, for kind introduction. And I really appreciate your effort to have this joint session between MSec and Fed4IoT. Although this is an opening remark, can I share my slide a bit?
Sure, I will stop sharing. You can now share.
Okay. So I want to briefly introduce what Fed4IoT, just for the information for people from MSec. We have 8 partners, 4 from Europe and 4 from Japan, and 2 companies, small and medium SMEs, EGM, Audience, and CNIT is an Italian research institute, and NEC from Europe, and we Japan, to companies and to academic institute. And our goal is interoperability of IoT systems, and we want to reduce the initial cost in developing IoT services. Because IoT systems are silos, we need to unite different IoT systems. So that's our purpose. We want to put together different IoT systems. And if you are from Japan, you are familiar with this CTOS concept. It is somehow now a buzzword generated by the government. So many people looking at what the CTOS is like. And we will try to serve for this purpose. Hopefully, we can use our product, our results to this direction. And yeah, federation is required. So we have 5 speakers, and you can see the face. And this is a brief introduction from Fed4IoT side. Hopefully, you can enjoy talks, and hopefully you get something from our presentation as well as from MSec side. Thank you very much.
Thank you so much, Iderani. I will now start sharing again. Okay, so now we kickstart the presentation with the MSec project, mainly the main goals and results. So I will give the floor again to Vanessa Clemente Nunes from Worldline, and then we have also the participation of our colleague from ICCS, Anthony Zlitke, and also from KU University, Akira Tsuge.
Thank you, Nadine. If we can go to the next slide. Okay, so first of all, I would like to introduce a little bit the MSec project, but also the consortium. If we can go to the slide before. Yeah, thank you. So MSec was born in July 2018. As a Europe and Japan R&D project, is financed by the European Commission, but also by the National Institute of Information and Communication Technology, which is the equivalent in Japan. The consortium is made by 12 partners, 6 European and 6 Japanese, and it's represented, as we can see, by 3 large industrial groups, Worldline, NTTEs, and NTT-DMC, also by 3 research institutes, ICCS, CA, and NII, and 3 universities, Keio, Yokohama National University, and Waseda University. It's also composed by 2 small medium enterprise, TST and M6S, and in addition to 2 commit cities, Santander municipality as a full partner of the consortium, but also, even it's not here, we have also the support of Fujisawa, which is a Japanese city, which has been giving support during the whole project in terms of pilot implementations. We go to the next slide. One of the main challenges today is that IoT systems tend to be built around the concept of IoT cloud convergence, integrating heterogeneous data streams within cloud infrastructures and thus benefiting from the scalability, the performance, and the capacity of the cloud. However, these architectures promote a centralized data collection and a processing approach, which introduce some limitations in terms of support applications and business models. Moreover, another additional motivational factor of how MSec has born sources in the IoT and the smart city domain contain sensitive information that can raise issues on privacy and data protection and integrity. If we go to the next slide, some of the, the next slide. Some of the main drivers for security enhancement, the one before, is that first of all, the increased use of IoT lately, the number of devices connected to the internet, including the machines, sensors, and cameras that make up the Internet of Things, continues to grow at a steady pace. It is estimated that by 2025, there will be 41.6 billion connected IoT devices. And the rise of the adoption of IoT has increased also the potential of cyber attacks. It's actually estimated that in 2018, there were over 30 million IoT attacks, which suppose an increase of 200% if we compare it with the previous year, 2017. Based on these 2 points, governments across the globe are focusing also on implementing some regulations regarding data security and privacy. Actually, lately, we have seen various regulations that have been introduced to strengthen the security of IoT devices and avoid misuse of data, such as GDPR. In addition, we count with the speed of the internet, the cloud, and the mobile device, as well as the development of self-driving cars and smart devices, and next generation technologies as in artificial intelligence, big data, blockchains, that will obviously facilitate the development of new solutions focused on protecting and giving an end-to-end approach to the IoT smart city applications. So with all of that, if we go to the next slide, the main objective sought by MSec during these 3 years of project has been to develop a framework that provides security and integrity of data traffic in an end-to-end approach from the device to the cloud to the application in a secure and transparent way. And in order to develop this secure framework, the consortium has based all the developments in reaching and analyzing the state of art of the different technologies, IoT, cloud, big data, blockchain, but also on techniques, methods, and mechanisms to reduce vulnerabilities. In addition, risk and threats on current IoT smart city solutions have also been considered for all the development of the different components that compose the MSec framework. We go to the next slide. On top of the platform, we have built also new IoT applications that have been tested during the last month across 2 smart cities, Fujisawa city in Japan and Santander city in Spain. Each of both recognize having already developed a long-term smart city approach. And within these 2 cities, if we go to the next slide, we have 5 different use cases to validate the infrastructure developed of MSec. We have conducted several pilots ranging from those that collect environmental data, such as noise pollution levels, temperature, air quality, garbage disposal, and so on. And also we have other use cases that collect home activity data to monitor aging people. We will explain anyways further details about each of the different use cases and pilots tested in the last month, so you can get more insights about it. The next slide. So here we present the main results and outcomes provided by MSec. First of all, we provide an end-to-end and trust infrastructure where IoT stakeholders can develop and operate new IoT applications for smart cities on top of it. We also provide a marketplace to facilitate the change of valuable data collected from devices between, so people can buy and sell this data through virtual currencies. Also, we provide a smart city ecosystem where city governments, researchers, business, startups, developers can connect and access to a complete set of tools and results of the MSec project. And also, we provide information based on the pilots of the different use cases that we have pilot. So stakeholders can also replicate, can get inspired to replicate the MSec approach. And for that, we also provide some tools like a value proposition and a business model canvas. So it's easy to understand each of the use cases and understand the revenue model and the value provided by MSec. The next slide. Okay, before explaining in detail each of these 4 main results, technically, I would like to highlight what the consortium has achieved, especially during the last year of the project. We provide a final consolidated version of an extensive elicitation of requirements for the project, which have been covered mostly by the different components and functional groups that we will see lately. We also provide consolidate risk version also and threats, and we have followed the stride model for that. we provide the final architecture of MSec. And also we provide the final prototype of the secure MSec core system components. So if we go to the next slide, we will explain more in detail what is about MSec and from what components are it's composed. So I will give the floor to my colleagues.
Thank you, Vanessa. My name is Akira Tsuge from Keio University. I'd like to introduce MSec IoT infrastructure. This is a figure of MSec IoT infrastructure as a whole. One of the major challenges of the MSec project is to build a platform for smart cities that meet the conflicting requirements of secure and open IoT platform. Next, please. For example, this is in the case of the PC and smartphone operating system. The more common and widely used platforms are the more essential measures against security attacks become essential. That is, open platform and security generally conflict with each other. Sorry. So we are challenging to establish flexible and scalable secure smart city platform in this MSec project. Next, please. This is again MSec whole infrastructure. Next, please. Okay. In order to realize these conflicting requirements, we have integrated project members' unique solutions. First, as an open IoT platform, it consists of components shown in this red frame. You can see the center of the red frame solutions, secure city data access. This is a core of the IoT platform. And also lower side, we have secure device layers and also secure and trusted storage. These are basically the general IoT platform components, but we add secure technology from MSec project partners. And also you can see the top right-hand side, IoT data marketplace. This enables IoT data to validate and send to marketplace and sharing the open variable IoT data to the widely in global. Okay, and sorry. Next, please. In this figure, I had a mistake. Same explanation of the yellow rectangle. This should be the secure component, sorry. So we integrate this red rectangle component and yellow rectangle component. It is they are secure component. So some security management tool or privacy protection solution and total end-to-end security system. We combined these components to the MSec as a MSec IoT platform. So we realize scalable and flexible, secure IoT platform for smart city. This is a whole MSec infrastructure. Thank you.
Thank you, Akira. I'm Antonis Litke from ICCS of the National Technical University of Athens. As already said by the colleagues, the MSec Marketplace is one of the vital results of the specific project. But to what it consists of? It's actually an asset, what we call as an IoT marketplace, an overall platform through which we can exchange Internet of Things sensor data and media easily, securely, and of course with the complete anonymity so that we are aligned with GDPR constraints. What it is, therefore, is to actually allow the real-time matching between supply and demand in the specific data coming from IoT sensors and media items. So actually, the Internet of Things devices and humans through mobile phones, through their mobile applications, they are providing data and they're consuming data through the specific IoT marketplace, given that there are the appropriate application programming interfaces. And all this can be achieved in what form? Through the use of a blockchain that can enable the virtual currency that we have created to flow across this infrastructure and enable the specific exchange of data and of course the purchase and the financial transactions that are over there. The specific blockchain that has been used is a Quorum blockchain, Ethereum-based blockchain. So we will have a chance to detail a little bit more later on when we're going to see the particular use case. And there is a set of smart contracts that have been implemented in Solidity that can actually enable the specific decentralized application that is that is part of the particular asset to take place and be implemented in the specific pilots. So later on, where we have a dedicated session for the presentation, actually for the particular use case, we will have a chance to dig a little bit deeper in this use case. Thank you. Vanessa?
Yeah, thank you very much, Anthony. So if we go to the next slide. Okay, so here we continue with another of the MSec resource provided, as mentioned before. It's regarding the smart city ecosystem. We provide a channel based on Slack where you can engage directly with the MSec community and raise any doubts or curiosities you may have about the project. You can share some feedbacks. We also provide, we have been actually working with the project live to achieve some partnership with some European and international projects. Some initiatives have been achieved with some standardized bodies like the Alliance for Internet of Things Innovation and so on. You can also find more information on the MSec website. We can also with EPSIS that has an existing network of more than 6,000 startups, small medium enterprise. You can also exchange information. And we have also performed during September an online contest where some teams engaged in the opportunity to present some innovative ideas to answer to two challenges raised by each of the cities, Santander and Cuisawa. And there were also 3 award winners for each of the cities based on the ideas that they applied. So, and here, finally, you can have also a view of the last MSec result, which is regarding the replication plan. I will not explain in detail each of the use cases since it's something that we will explain in the next section. But so you can have an example of what we provide. It's also for each of the use cases, we provide a value proposition, also a business model canvas where you will find some information regarding key partners and the revenue model and the cost. So you can get inspired if you want to replicate one of the existing use cases or to create a new use case based on top of based on the infrastructure of MSec. So thank you very much.
Thank you so much, Vanessa. So now we will move forward to the second part of our MSec presentation, which relates with the use cases that have been implemented throughout the project. So I will ask my colleague Alberto Puras from TST Sistemas to present use case 1, secured IoT devices to enrich strolls across smart city parks.
Hello. Hello. Good morning, everyone. My name is Alberto Puras, and I work at TST, an SME member of the M-Sec consortium. I'm responsible for the implementation of use case 1. Use case 1 pilot is aimed at monitoring variables that are considered relevant for the well-being of citizens and useful for municipalities to carry out analysis and take effective management decisions. For instance, the kind of variables that have been considered within the pilot are representative of the air quality and the environmental conditions, as well as the overcrowding of areas of interest. Besides, another important aspect that has been considered in the security is the security, sorry. In fact, the monitoring system must operate in a secure and safe way so that it can be assured that the information is delivered without suffering of external tweaks, which may lead to erroneous decisions by the municipalities. So, Pilot 1 is mainly based on 2 different IoT devices that have been developed within the project and deployed in Las Llamas Park, one of the biggest and more important parks in the city of Santander, located in the north of Spain. One of these devices is the so-called cloud counting device, which is capable of detecting Wi-Fi and Bluetooth MAC addresses, which are used as an indirect estimation of the number of people in attendance in the surroundings of the specific spot at the moment in time. The device that has been deployed in Las Llamas Park is located in one of the hot spots of this park, just in the level below its restaurant. So we assure with this location a good measurement of the number of visitors of this park. And the other device, which has been developed within the project, performs environmental monitoring duties through 5 different sensors, namely temperature, humidity, CO2, volatile organic compounds, and noise. The locations where 5 of these environmental sensors have been deployed imply covering, on the one hand, the children's playground, and on the other hand, a complete cross-section of the park, going from the border with the University of Canterbury campus to the other side, which is next to a residential area, and cover as well the city motorway, which separates this housing zone from the park. To fulfill the security requirements within this layer, the IoT devices were designed so that they include novel hardware security mechanisms that prevent these sensors nodes from external attacks. Besides, an MQTT connection is used to transfer the data to the upper layers. Apart from the IoT devices, users interested in taking part in the experience can find QR codes scattered throughout the park. These QR codes provide information about its flora and fauna. This way, users can enrich their experience when strolling through the site. On top of that, a web application was developed. This application enables the users to access and rate the interest and the quality of the data provided by this pilot. So I think that's all from my side. Thank you for being here.
Thank you so much, Alberto. Now we move forward to our MSec use case 2, also with Vanessa Clemente Nunes from Worldline, entitled Home Monitoring Security System for Aging People.
Thank you, Nadine. Okay, so if we go to the next slide, here on the right side, you can see a screenshot of what we provide as a web application, which is called Senior Care, to fulfill these use cases. It's mainly an IoT platform composed of home sensors. We have sensors related with movement, door and window opening or closing, also sensors of bed occupancy, and some also smart plugs that provide data regarding electrical activity detection in appliance. So all of that enable remote monitoring of the daily activity of older people who live alone. And the solution allows the configuration of alarms based on data generated by each of these sensors. Alarms can be based in data of one sensor, but also of data of a combination of several sensors. To alert users to any concerns regarding the security of well-being of elderly people living alone. So the solution aims to guarantee the security and safety of people who may be at risk due to factors of age, frailty, loneliness, or dependence. And we have been tested during the last year the pilot with Attendees, which is a teleassistant company, and they have been piloting the solution with 5 end users. What MSec provides mainly to the solution, well, one of the great challenges faced by this kind of solution is that has to do with the security and integrity of the data collected. The main problem is for its applicability and scalability, actually. The sensors deployed in the aging people residence are continuously collecting personal information that, for instance, a malicious actor can use to track and commit malicious actions. No? However, thanks to MSec, it's possible to add additional security mechanisms that prevent external attacks that can lead to erroneous actions by actually the teleassistants, the teleoperators from the teleassistant company. So one of the benefits provided by MSec is the high level of security that provides the use of the quorum blockchain, not allowing tampering because the data is stored in the blockchain and all the data stored in the blockchain is immutable. It also reduces the threat of being hacked thanks to the blockchain. Another asset that also increases the security for sensitive data is the crypto companion database that, together with the blockchain, what makes is allows to have sensitive data stored in an encrypted database, link it with a hash, save it in a blockchain as a transaction. Furthermore, we use a component called SensiNAT, which provides also a fine granularity access control mechanism to allow only authorized people to read raw data or interact with the IoT devices. So these are the main security provided. Also, we use the end-to-end security component, the security manager, that also provides some kind of access security into the functional group of the secure and trusted storage. Thank you very much.
Thank you so much, Vanessa. I would now like to give the floor to, again, Akira Tsuge from Keio University, presenting use case 3, secure and trustworthy mobile sensing platform.
Thank you, Nadine. I'd like to explain about use case 3. Next, please. Use case 3 is IoT platform itself that securely and openly distributes data, such as environmental sensors and drive recorder cameras installed in garbage trucks. We have developed a collaboration with Fujisawa City, Japan. And the reason why we install the garbage truck sensor box. Garbage trucks is running in Fujisawa City every day. So we don't need install everywhere the sensor, lots of sensor to everywhere in Fujisawa City. So this is a original idea. So every day, many IoT data coming to the KO server. So we are using this solution as a use case 3 of MSec project. Next, please. I'd like to explain about the core of this use case. This is a secure SOX file. Generally, sensor and application are connected point to point. But KO SOX file is based on publish subscribe model. So basically, data provider side and receiving side. Sorry, next please. Yes, thank you. Provider side and demand side are not connected directly. So we can deliver flexibly, more flexible delivering to the data demand side. We use this KO SOX file and powered by a secure solution from MSec partners. We use this as the core of the mobile sensing platform. Next, please. So center of this figure, you can find the KO SOX file, and we use from left-hand side mobile sensing platform installed by garbage truck, and also we use web scrolling data and participatory sensing. Next, please. Like use case 4, smart city report, smartphone application. This is input from the user. This is also the sensor data. So we use many various IoT sensor data to the SOX file, and also user receiver side can subscribe which they wanted data and analysis and visualization and something like that. This is a basic concept of the mobile sensing platform. Next, please. And this is an example of a garbage truck drive recorder camera analysis. This is a example of analyzing the amount of the garbage. This is a camera image from the installed in garbage trucks. We can count the amount of garbage by using the deep learning algorithm. So we are using this kind of the image processing and IoT sensors. We analyze various data. This is a example. Next, please. Okay, so as original use case 3 is based on the garbage truck mobile sensing. But next, please. As next use case 4, we are using the smart city report application as a participatory sensing. This is also input of the SOX file. And next, please. And also we are trying the various sensor data, not only garbage truck, but also we are now trying the route bus sensing, especially everyone concerned about infections of COVID-19. So we analyze congestion and CO2 sensing in the bus. This is also input of the SOx fire. Next, please. And also we install the CO2 sensor and PM 2.5 sensor to the restaurant in Fujisawa City. So we analyze every day this environment sensor data in the restaurant. This is also everyone concerned about the infection of the COVID-19. So we detect this kind of the environmental data. And also this could be the input of the SOx fire. So, and we can send to the receiving side. And also, next please. And also, as Anthony's already explained, with the marketplace, we integrate. This is also via KO SOx fire. We integrate marketplace feature to the use case 3 and also use case 4. So this is a current use case for mobile sensing platform. And in future, we will provide scalable and flexible IoT platform. This is a use case 3. Thank you.
Thank you so much, Akira. And now for use case 4, I would like to give the floor to Tadashi Okoshi, also from Keio University, entitled Secure Effective Participatory Sensing of City Events.
Yes, I think you can hear me. This is Tadashi Okoshi from Keio University. So we will present the use case 4, which is secure effective participatory sensing of city event. And it's cross-border trial, actually. So as you can see on the right-hand side figure, we are developing a system called Smile City Report. Actually, that is a smartphone application along with the corresponding server-side logic. And this Smile City Report system is a system that allows citizens or even the visitors of the local area to report the events or what the happenings of the local area in a really secure way, where the reporting user can protect his or her privacy information, as long as the privacy information of some other people who happen to be inside the photograph. So this smartphone application is basically Instagram-like photo sharing application. So there's a screen like timeline, and you can take a photo of the venue or the scene or the beautiful view in the city, and you can report that to the timeline. But the really distinctive feature of the Smart City Report is that, as you can see, we have 2 cameras, in camera and out camera on our smartphones. So this application takes a pair of photos simultaneously. So as you can see on the right-hand side figure, when you take a photo of the beautiful sunset, the application takes a photo of your facial expression at the same time. Then inside the application, the degree of smiles, how well, how nicely you're smiling, will be calculated by the AI logic. Then on the blue cycle area, so inside the protected community, you can share the photo of the scene and the photo of your faces and the degree of smile, 90%, 80%, or whatever, among the community group members. And in addition to that, you can share some of that information, like the photo of the sunset, and only with the degree of smile, 80% in this case. That kind of information, the partial information, will be shared more public smart city network, or even to the IoT marketplace, which is described later today. So we built this kind of system, and we are having a multiple user trial right now within Fujisawa City in Japan and Santander City in Spain. So could you go to the next slide? Yes. So basically, I already explained some of the architecture side of this system, and we are right now this week having a simultaneous trial between Fujisawa City and Santander City. Next, please. So next slide, please. Yes, so these are some of the screenshots from our first, field trial, which happened last November. And these used to be, this was a trial at the kind of a city jazz event, jazz festival in Fujisawa City. And we have multiple different themes, like a hashtag in Instagram application. So where some question will be asked, something like how crowded is the train station, or how nice jazz is going on in the stage 1 or stage 2, or what are nice restaurant menu around this area. That kind of question will be asked by the system. So the reporter or citizen can answer those questions by taking a photo of the venue, of the restaurant menu, or the jazz event, or whatever. Then, could you go to the next? In this kind of system, as we already mentioned, protecting privacy of people is really important. Of course, we have to protect the privacy of reporting user, but at the same time, in the photo of the scene, there can be some people or some other privacy-aware project which happen to be taken inside a photo. And we have a special web API-based AI engine, which is called Gyanonymizer, which allows the photo to be modified in a way that any privacy-aware information inside the photo will be erased. So when you see this picture at the original, at the upper side and the bottom side with Gyanonymizer cases, so you can see that in these cases, cars have been erased from the figure, the pictures, right? So these are actually detected by the Gyanonymizer engine, and with neural network model, yes, the people, pedestrians on the street or cars on the street, those objects have been modified and have been erased so that we can protect those people's or those cars' privacy information from the photo report on the Smart City report. Could you go to the next? Yes, so applying this Gyanonymizer AI logic onto the Smart City report, you can see that some of the photos on the right-hand side. So for example, in the normal photo, there are so many people sitting down on the stage of the jazz event, but by using Gallerymizer, those privacy-aware, privacy-sensitive objects have been erased. And on the right-hand side, there are multiple people lining on the queue. Yeah, they are watching the jazz gigs, but those people have been erased. So we are right now conducting multiple simultaneous trials in Spain and Japan to see how effective this system is working, and in terms of the acceptance of this system by the trial user. So this is it for the use case 4. Thank you.
Thank you so much, Tadashi. And now we will go to the final use case of the MSec project. And again, I will call for Anthony Slitke from ICCS to present to us the Smart City Data Marketplace.
Thank you very much, Nadine. So now we can, let's say, have a more close look on the particular things that the marketplace use case delivers in the overall project concept. So besides being a technology platform, as already said by the other colleagues, we have a dedicated use case that as a particular use case serves the purpose to create what we call the MSec overall marketplace, where data that are being collected in the particular field trials for the evaluation of the MSec results can be somehow exchanged, traded in both Japan and Europe, while at the same time, as you have seen also, we can ensure the security in all those layers. So the idea here is, okay, once you have the market, once you have the technology there that can be the basis, that can facilitate a specific exchange of data coming from Internet of Things sensors and mobile devices, mobile applications, how you can operate this in such a way that can be meaningful and can be useful also to the other use cases, to what we call the overall cross-border scenario that we would like to have. So in that case, the overall approach that we are having here is actually to have the necessary application programming interfaces to be able to connect to the various sources, as we have seen with the different and the many applications and the many other platforms we have there. So the big challenge there was actually to be able to integrate things, to integrate the different data sources along with the necessary databases that should be there, and at the same time be able to allow the specific flow of data, the specific exchange, so that we keep overall the constraints of having the integrity of the data on one side, and at the same time be able to provide the necessary privacy for all those data that are being there. So this is the main concept of the marketplace. Next slide, please. As far as it concerns the different technical approaches that have been followed here, the idea is actually to have a decentralized application, and this is why we have utilized the technologies from related DLTs, like for instance the Quorum blockchain, where at the same time we can have different and more complicated workflows on how the specific functionality can be delivered. To this end, we have deployed also the Node-RED framework that can actually orchestrate the different services that are being provided as functionalities in connecting all those pieces of services that we would like to have. Smart contracts, as already said, I mean, as part of the Quorum blockchain and the Ethereum-like blockchain that we have deployed, so that we can allow also the public and open, the permissionless blockchains to be delivered. We have implemented a set of various smart contracts in Solidity that are responsible for creating at first the MSec token. So actually it's going to be this is the currency that enables the flow of the different and exchange of the different data that are being there. The sensors smart contracts, so all the different smart contracts that will allow to register the sensors and record the transactions on the different data providers that are being there. And of course, a smart city data smart contract, which is responsible for having data from the different smart cities that can later on be further joining our solution. So all these data sources are being connected through the Node-RED flows, and this gives us an opportunity to create a rich variety of different aspects that we would like to have as far as it concerns the functionalities to be delivered over Marketplace. Next slide, please. So here just some views that you can have for users. This is, let's say, the main dashboard where the users can have access to the specific marketplace. Here you can see that users are able to browse and buy different data, upload data, like for instance, in the particular use screenshot that you're seeing here, this refers to photos that are being shared and can be sold at the same time. Next slide, please. Here, another view on the integration that the specific files have with the interplanetary file system. So the data storage that we are using so that we can allow the overall decentralized and distributed nature of the data sources and the data repositories that are available. And at the same time, on the left side, on the right side, you can see the browsing, let's say, functionality someone can have while he's interested in purchasing a specific picture, for instance, as you can see. Next slide. The same applies with sensor data as well. So there is a variety of different sensors, as you can see here, for instance, not only temperature, but also relative humidity. And those buying those data can actually allow a specific subscription actually to the particular sensor that can further enhance business models that someone would like to have. And all these can be implemented with a specific MSec token currency that we have created as part of the particular smart contracts. Next slide. As already said also by my colleagues previously, a very important aspect is that, okay, once you have the specific marketplace, you would like to integrate it with the rest of the platforms that are available, like for instance, Soxfire in this case, just to give an example, and the Smile City report, of course, because what we call the use case of the marketplace is a cross-border use case. So we should provide the different means to integrate the core platform, the blockchain-enabled platform of the marketplace with the different solutions, like for instance, Soxfire and the Smile City report. So to this end, new features that have been created, have been integrated in these kind of platforms, allowing for different registration of sensors in the mode of the public subscribe model that has been already previously described, and also the ability to purchase, to exchange the different data through the use of the token, of the smart contract token that we have created that can enable the specific currency to flow across this blockchain. Next slide, please. So to this end, the specific use case had a wide set of particular key performance indicators that we covered within the project. At the same time, we are still having an evaluation phase that is running through different questionnaires. So the number of transactions that are going to be implemented over the particular blockchain, the number of the different data sources that are going to be integrated, the number of users who are going to participate in the overall pilots. So those key performance indicators have been achieved as far as it concerns the particular use case. And are being currently evaluated as well through the use of a questionnaire that is taking place as part of the evaluation of the overall pilots. Thank you very much.
Thank you so much, Antonis, for presenting us use case 5 related with the MSec Marketplace. And now to finalize and then give the floor to our colleagues to present the Fed4IoT project, I would like to give the floor to the cities that have worked with us over the past 3 years, and for you to know what was the added value for them and their participation and involvement in this project. So first, I will give the floor to the Santander municipality with Sonia Sotero Muniz. Sonia, the floor is yours.
Thank you very much, Nadine. Good morning and good afternoon, everyone. As Nadine introduced, my name is Sonia Sotero and I belong to the innovation area of Santander City Council. And I would like to start this presentation mentioning that Santander is nowadays an international reference within the smart cities. And this is due to the active participation in European research projects, which turn the city into a urban laboratory, as well as the development of different city initiatives in which the technology has been applied in order to improve the efficiency in the management of the public services. So on the left side of this slide, you can see the logos of the different European research projects in which Santander municipality has participated since 2010. Is a total of 28 European research projects, and 3 of them are European-Japan collaborative projects, such as Clouty Festival and, of course, the MSec project. On the right side of this slide, you can see the different city initiatives in which the technology has been introduced in order to improve the management of the different public services. In addition to this, lessons learned from the different pilots implemented in the European research projects are integrated into the city initiatives. Next slide, please. Okay, the next one, please. Okay. Focusing on the European research projects, the role of Santander City Council in this type of projects, such as the MSec projects, includes different types of tasks, such as the collaboration with the technical partners and the staff from different municipal services in the definition of the pilots to be implemented in the city, aligning the project objectives and the needs of the city. In addition, we try to facilitate the implementation of the pilots in the city, for instance, in identifying the most suitable locations for the deployment of the different devices, and also trying to speed up the bureaucratic issues, such as the license required for this deployment. And finally, we also work in the involvement of real users to take part in this pilot experience. In the scope of the MSec project, Santander City Council is participating that are being implemented only in Santander, in the city of Santander, as they are the pilot 1 and also the pilot 2. And we have also participated in the 2 cross-border pilots that have been presented by Tadashi and by Antonis. So with this slide, I try to illustrate one of the pilots that is being carried out in the city of Santander, and that has been introduced by Alberto Puras. And these 3 pictures show the web page that has been developed within this pilot experience, showing the location of the QR codes that can be read by the users and that are scattered in the Las Llamas Park. The second picture shows a group of friendly use experience was open to the whole city. And the last picture shows how one of these participants in the pilot is reading one of the QR codes that is installed in the park. And finally, I would like to say that it's important to highlight the strong collaboration with all the MSec partners, especially with the Japanese ones in the implementation of the cross-border pilots. So thank you for your time.
Thank you so much, Sonia, for sharing your experience and the experience of Santander City. I will now, last but not least, give the floor to Tatsuo Fukuda from Fujisawa Municipality so that he also provides the feedback from the Japanese city.
Okay, thank you, Nadine. Hello, everyone. I'm Tatsuo Fukuda from Fujisawa City. Today, I would like to talk about my impressions of MSec project that we were participated in as a field trial city. Sorry, I don't speak English well, so I will ask Keiko to translate for me. 藤沢市はこれまで3回日朝共同研究事業に参加しました。最初はクラウティプロジェクト、次にビッグクラウティプロジェクト、そして今回の MSec プロジェクトです。
Fujisawa City has participated in the EU-Japan Joint Research Project 3 times so far. First, Cloudy Project, then Big Cloudy Project, and this time, MSec Project.
それぞれのプロジェクトがビッグデータの利活用を目標としていたことは、スマートシティへの取り組みを進めている自治体としても大変重要な取り組みでした。
The goal of each project to utilize big data was very important for local governments and that are promoting smart city initiatives.
特に今回の MSec プロジェクトでは、収集したデータを安全に利活用するということ、これについて今後のビッグデータ利活用の中でも特に重要な研究だったので、実証都市としてもこの MSec 技術の内容と合わせて、パーソナルデータの取り扱いに関する研究についても興味深いものでした。
In particular, the safe utilization of the collected data in MSec project was very important research in the future utilization of big data. So it should be combined with the components of this MSec technology as a field trial city. The research on the handling of personal data was also interesting.
また、日本の自治体の抱えている課題が、ヨーロッパ側の自治体が抱えている課題と似ていることも、私としては大きな発見で、日曜での研究が重要であるとも感じています。
It is also a big discovery for me that the issues faced by Japanese local governments are similar to those faced by local governments on the European side. And I feel that collaboration research projects between Japan and Europe is very important.
MSec では予定していた実証実験が新型コロナの関係で藤沢ジャズフェスティバル以外、なかなか思うように実施できなかったことが非常に残念でしたが、このような研究に参加できたことは貴重な経験となりました。
In MSec project, unfortunately, the planned field trials could not be carried out as expected, except for the one collaborating with Fujisawa Jazz Festival due to pandemic situation. But it is valuable to be able to participate in such research project. It was a great experience.
日本はまだまだ IoT やビッグデータなどデジタル技術の活用に関しては遅れていると感じています。MSec での研究がさらに発展し、データ利活用によって都市の課題解決が進み、 住民の QOL が向上していくことを期待しています。
I feel that Japan is still behind in utilizing digital technologies such as IoT and big data. I hope that MSec research results will be further developed. Data utilization will advance the solution of urban issues, and the QOL of residents will improve.
今後もチャンスがあれば、実証自治体として参加することで、スマートシティへの取り組みが進められればと思っています。
If I have a chance in the future, I would like to promote the smart city initiatives by participating as a field trial city.
Thank you very much.
Thank you so much, Tetsuo and Keiko, for the translation. I will now stop sharing and give the floor to our colleagues from Fed4IoT for also presenting their project results and main achievements.
Okay, so let me share my screen a bit. Give me a moment. Okay. Almost ready. Okay, so first of all, let me start my video. Okay, so you should see me, and now I share my screen, and it's okay. I can share my screen, turn off desktop. Okay, so we go. Okay, so first of all, thanks to who organized this webinar, in which we can share our result between us and also with external people. And I am Andrea Detti. I am a professor of the University of Rome Tor Vergata, and I work for CNIT, a large consortium of university in Italy, that whose interest is mainly in communication, computing, and ICT in general stuff. And I'm presenting the result of our project that is named Fed4IoT. And yeah, so let's start. When we want to design an IoT application, usually an application developer must deploy the IoT infrastructure. IoT infrastructure that is made by things like sensor, like actuators, a thermometer, water system controller, and so forth. So things are in the hand of application developer, and then usually the data of the things are produced by the things are collected by a kind of integration platform that we name here broker. And example of integration platform are integration platform that follow specific IoT standard like 1M2M, NGSI, NGSI-LD, and so forth. Indeed, many standardization efforts specifically focus this component, the broker, the integration platform, by defining their application programming interface and data formats. And the different standards have different API and different data formats. Well, all this infrastructure that is made by things, by the broker as integration platform, is actually a server or a cluster of server, and can be also component by some controller or agents that adapt the API or data model of objects to the API and data model used by the chosen broker. Well, all this infrastructure made by things, translation agent, and broker is currently in the hand of IoT developer. So the IoT developer not only has to develop his or her application, but has also to manage the infrastructure that produces the data for his application. And this, we name this infrastructure IoT silo, and this infrastructure is usually named as silo to, let's say, highlight the fact that this infrastructure are to some extent isolated because are used only by a set of application of a specific user that is also the owner of the infrastructure. And to support the development of application, IoT application, cloud providers offer some services that are mainly focused on data processing rather than on providing the infrastructure. So cloud provider do not provide the data. They provide some software component to process and storage the data, but they do not provide the data. For instance, in this picture, this is an example of processing chain that we have built using Microsoft Azure IoT services. We have usually an IoT hub component that fetch the data from integration platform broker or directly by things, and then insert this data in a processing pipeline that can trigger function and store data in a database and so forth. But actually, this part of the game is in the hand of IoT application developer, as well as the eventual application. So this is a reality check of how today usually IoT applications are made. Well, what we want to do is to create a cloud of things that virtualize what is still real. That is the IoT silo. So we want to virtualize this part that nowadays is not virtualized. In this way, the application developer can focus only on the application without taking care also of managing the infrastructure that provides the application. It can narrow its business to the application in this way. Using our cloud of things, we are going to, we have real things and integration platform that are provided by, let's say, thing provider or infrastructure provider. The data of these real things are inserted in our cloud of things, and a user can create, using the service of our cloud of things, virtual silo. In turn, virtual silo can be connected to upstream service offered currently by cloud providers. So we are not, let's say, replacing some services already offered by cloud providers. we are extending the pipeline of cloud virtualization, introducing in this pipeline also the things. And so we are going to create an infrastructure, that a system, that is a platform that offers services that are complementary to those currently offered by cloud providers. Let's see what a user can do with our platform. Well, imagine that we have a tenant, a user, that wants to build a watering system that is made by his things, like watering device in his garden, and also this made by virtual things that he wants to rent. So the tenant, first of all, has to create a virtual silo. Like you create a virtual machine, with our platform, you can create a virtual silo. And virtual silo is, when created, is an empty box that contains an IoT broker based on a standard technology that user can choose. So user can prefer, I like one end-to-end, another like Orion LD, another like NGSI. User choose. Like in a virtual machine, you can choose your operating system. Here, tenant can choose the integration technology and integration standard that he prefers. After that, the silo is created. The user can add to this silo virtual things that are in the portfolio of the platform. Virtual things can be face detector, person counter, or also this is a detection of light detector, and this is an hygrometer. These virtual things, the data of these virtual things are of interest of the user because he has to build a watering system, and therefore he adds an hygrometer and a light detector to his virtual silo. But he does not rent other virtual things because not of his interest. Okay. So when these things are added to the virtual silo, the broker, the user, start to see the data of these virtual things looking at this broker. Okay. And after that, the user can also connect its own real things to the broker, like a watering system, and eventually develop the application that fetch the data from the IoT broker and control, for instance, the watering system. So this is our platform that is named VARIOT, whose acronym is Virtual IoT. This is our VARIOT in action. Making a comparison between cloud computing and our proposal of cloud of things, well, we can say that on the left, we have cloud computing. On the right, we have our cloud of things concept. In cloud computing, we have an hardware provider that can be usually also the cloud provider itself that put in place real device like servers. Okay. Then we have a component that is named the hypervisor that create virtual hardware that that are combined together to form a virtual machine. And on top of this virtual machine, the tenant can install an operating system that can be Windows, can be Linux, or whatever. Yeah, now let's move to our cloud of things. Well, we have things provider that are provider of data and real things that could be sensor on actuator. We have the cloud of things provider that thanks to the service of a object that we have named ThinkVisor, create virtual things. The tenant, virtual things, the tenant can choose the virtual things that form its virtual silo. as well as a tenant of cloud computing can select which hardware form its virtual machine. Here, the tenant can select the virtual things that form a virtual silo. And the tenant can select which is the standard for the data and API of his data. Like in cloud computing, the tenant can choose the operating system. That's the idea. Use cases. Like in cloud computing, we have, let's say, targeted two kinds of use cases in terms of kind of services. We can have public services and private services. So like we have public cloud and private cloud. In case of public cloud or public cloud of things, we have the framework is that we have an IoT system provider that provides the infrastructure, real infrastructure that offers service to a cloud of things provider that in turn offer virtual silo to the IoT app designer. As you can see, in this way, we have decoupled who developed the application from who provide the infrastructure. And this decoupling, it's currently not here, and is what, in the IoT framework, and what has made cloud computing so useful. So we are trying to create this decoupling also in the IoT domain. Another, let's say, use case is for private service. So many times, software developer use virtual machine to develop their application to avoid that his operating system becomes dirty of software libraries and so forth. Many times you develop your application in a virtual machine and you then, to avoid, to make dirty your operating system. And, or because you want to isolate your application also for security purposes, so that if someone attacks your application, the damage is limited to the virtual machine and not to the whole server. Yeah, the same idea can be applied for a cloud of things. You can develop your IoT. Imagine that you have a production IoT system, okay, that is running, okay, and someone have an idea and want to develop a new service. Instead of testing the service in the real production system that can create problem, well, the developer can test his application in a virtual silo, like he can test his application in a virtual machine. That's the idea. And the data of this virtual silo can be provided by virtual things that take data for the real production system. Now we have talked about virtual things. So, but it's the time to, let's say, explain our thing virtualization concept. For our project, thing visualization means creating the illusion that a thing is present by producing the data or provoking the action it would have produced or provoked if it was real. This is our definition of thing virtualization. Who make this magic is an object that we name a ThinkVisor, and ThinkVisor create the data or of a virtual things using the data coming from real things, but even more. So thing virtualization is not only a matter of, let's say, analytics, but can be also something else. Can involve also the control, the physical control of some devices. So imagine that you want to create a virtual things that is a camera in a given position that take picture. like for instance, a camera in a parking, okay, or camera in an arbor to take the picture of your boat, because you like your boat and you want to take a picture of your boat. Well, you can create these virtual things, the illusion of having a camera fixed in a position, taking a drone, instructing the drone to fly over your boat. When the drone is here, take a picture and send the picture to you. You have the illusion to have a camera fixed in a position, but actually that camera does not exist. What exists is a drone that moves, take a picture and send the picture. So we have emulated the presence of a fixed camera not only to some analytics, but also controlling an object. So thing virtualization can be something more than analytics. And the things that we have that we are able to virtualize, the virtual things, can be virtual sensor that produce data, like a virtual face detector, virtual person finder, hygrometer. So this is phrase that is simply a data copy. In case of a virtual face detector, we can take, for instance, a picture from a camera, apply some analytics, and create an event if a picture, if a face is detected. Using the same things, and here there is a concept of thing sharing, we can elaborate the stream of image and count the number of persons, and we have created another virtual things. But we can also simply copy the data of our real things. And this is similar to, let's say, transparent virtualization. But virtual things can be also virtual actuator, like rent a drone. You can rent a drone and control the drone, or door locks or lamps, and so forth. This is the variant architecture. Well, variant architecture is a microservice-based architecture, completely based on Kubernetes, that support edge computing in the sense that it's optimized to be distributed in different data center and can also include edge location. And it is open source. Yeah, so the architecture provides that the platform is organized in zone. Zone are main data center, okay, or edge data center. And in each zone, you have thing visors and virtual silo that are actually Kubernetes pods. And thing visor interact with real things to create virtual things. You can have more thing visor because you are interacting with many real things. And a thing visor can create many virtual things. And you have virtual silos that are made by an IoT broker and an HTTP broker. Why two brokers? Well, because if you look at real IoT application, sometimes you need the context data that are, for instance, the status of something, the temperature, or control command like switch the light on, switch the light off. This kind of small data is allowed to control or monitor a context. Okay? But in IoT application, you can also have large data like video streaming. So this requires different performance. And for this reason, a silo contains two kinds of broker. One broker IoT broker that follow an IoT standard like 1N2N, free NGSILD or whatever, through which you can access context data offered by virtual things, and an HTTP broker that make possible to access large content like the picture or video streams offered by virtual things. So virtual things can actually offer context data and large content. And when you add the virtual things to your virtual silo, what happens is that the data of the virtual things traverse distribution system, arrive in your vSilo, and are exposed through the broker. And we have two kinds of distribution system. One for targeted for context data that is based on MQTT, and one on based targeted for large content like video streaming and so forth, that is based on HTTP standard. Okay. The MQTT distribution system is made by a sector, a distributed cluster of MQTT broker that interact each other. Okay, and we have one single broker per data center. And instead, the HTTP distribution system is made by a distributed cluster of HTTP proxies, specifically Nginx, that we have one per data center. Okay. And yeah, so this is the data plane of our architecture. The ThinkVisor take data flow from real things and create data flow, contextual data of the virtual things that the ThinkVisor manage, and create also content like video streaming and so forth. The contextual data traverse MQTT distribution system, arrive to the virtual silo that has whose user has decided to insert related virtual things in his vSilo, and then are exposed through the IoT broker. Okay. Same story for content. This platform has to manage interoperability of data format and API. Because our position is we do not want to create another standard. We do not want to create another IoT standard, but we want to design a platform that is able to integrate different IoT standards, current and forthcoming, in a kind of continuous integration of IoT standards. Well, so to support this, let's say, a goal of interoperability and continuous integration of different standards, yeah, we use this, let's say, solution. First of all, the ThinkVisor, when the ThinkVisor implement the API and data format, support the API and data format of the real things from which it fetch information. In this way, the provider of real things should not create an agent for our platform, transform its data format. No. This is a job of ThinkVisor, fetching the data according to the external data format used by real things. Then the ThinkVisor translate this information in a neutral data format, intermediate data format, that we have chosen to be NGS ILD. It's a novel IoT standard where we are strongly, let's say, involved. When this data is transformed in this intermediate format, this data reach the IoT silo that are interested in this virtual things, and the IoT controller inside the virtual silo carry out a second translation from NGS ILD to the model used by the broker. So the same information can appear in a one-to-one format if this is a one-to-one, if the user are chosen for this vSilo and one-to-one broker, or can appear in an NGS ILD format if this user prefer NGSI for his silo, head silo. So the same data appear in two formats, and this format is not a Fed4IoT format. It's the format chosen by the user. So in this way, we handle interoperability through the introduction of an intermediate neutral format that has been chosen among a set of possible ones, and we choose an MSec because we recognize that can be easy translated in other formats. With this allows our platform to integrate many IoT standards. And indeed, for instance, we have used our platform to test open source implementation of different IoT standards and in parallel. So, for instance, we made this test creating virtual things that produce fake data. And we have created different consumers that create a virtual silo that receive the data of these virtual things. But they use a different virtual silo with different open source broker. And so the same data is received by this different virtual silo and exposed to the user. In this way, we can make a fair comparison of different IoT brokers. And for instance, we noted that the average latency of Mobius and broker, depending if they use HTTP or HTTP, is this one. Mobius is a 1 and 2 broker. This is the latency of, for instance, experienced by using an Orion LD, an Orion broker that is a broker of fewer formulation, Orion LD that is NGSI LD broker, and Scorpio that is another NGSI LD broker. So this is measurement made using can be done using, for instance, our platform. Okay, all together, because we instantiate concurrently different virtual silos. Okay, we also can make measure on the consumer CPU and memory of different broker and so forth. So Variat is able to implement many IoT standards in a single platform. Currently, Variat is deployed in. We have a running test bed. One zone is running in European data center of Microsoft Azure. Another zone is running in Japan data center of Azure. The two data centers are connected by a VPN, and we also have an edge computing zone in Waseda, so in Waseda University. So actually, we have 3 data centers, and we also have a fog node that use another kind of on a Raspberry Pi. It's a very fog node, so it's all belonging to the same Kubernetes and Variat platform. And the user can choose where to deploy ThinkVisor or where to deploy the silo. Obviously, our recommendation is that to reduce latency, ThinkVisor must be deployed close to the real things that produce data, and virtual silo should be deployed close to the user that use the virtual silo, so that you can deploy in this way the ThinkVisor. In order to, let's say, optimize the deployment, as I mentioned, you can control where to deploy. And another, let's say, optimization is that ThinkVisor and vSilo are connected to the broker of their zone, and this provides low latency because, for instance, imagine that you have a vSilo here, and you have a ThinkVisor that produces the data that are of interest of this vSilo. So the data are simply moved in the same data center. Okay, so in this, therefore, create a low latency. If I control where to deploy. And another point is that we have designed a distribution system so that it supports multicast distribution. This means that if you have a real things that create the data that are managed by the ThinkVisor to create the data of a virtual things, and imagine that in Europe you have different vSilo interested to this data. This data is sent by the gateway of Japan zone to the gateway of European zone MQTT broker or HTTP broker only one time. Then this gateway, thanks to caching or other stuff, carry out replication towards specific vSilo. This is super important because imagine that you have a, this is not the case, this is a hygrometer, but imagine that this is a full HD camera and you want to see your videos from here because of interest of different vSilo. So if you do not implement this kind of, let's say, multicasting, you have one stream per vSilo over the EU Japan link, and this means that you have created an architecture that doesn't scale very well in distributed environment. Okay. So we have managed this kind of topology routing and multicasting to allow the scalability or distributed infrastructure. As I said, you can access our let's say software here, various GitHub here. Okay, so you can access your software here, and we have there is a complete README that describe how to deploy stuff on Kubernetes and how to add which are the command line interface that you can use to create a virtual things and so forth, to log in, register, yeah. Yeah, so currently the implementation offer support three kind of IoT standard. 1 and 2M, NGSI and NGSI-LD. This means that the user can create vSilo with these three technologies. And regarding NGSI-LD, we have three kind of possible broker. One is the Scorpio broker that developed by NSC. Another is the Stelio broker developed by supported by Etsy, but actually developed by EGM. These are two partners of the project. And then we have also an Orion LD broker. For what concerns 1 and 2M, we have integrated the Modbus broker for KETI, Future Internet Lab. And for what concerns NGSI, we offer broker that include Orion broker from the Fiber Foundation. We have developed different ThinkVisor. For instance, ThinkVisor that control a Philips Hue lamp. ThinkVisor for face recognition. ThinkVisor developed using NLC technology that is named FogFlow that allowed to create a complex ThinkVisor and distributed ThinkVisor. And we also have some other ThinkVisor like ThinkVisor, Weather ThinkVisor, or Hello World ThinkVisor that provide information about temperature, weather of cities, and Hello World ThinkVisor that simply periodically write Hello World. We also have other ThinkVisor. This is the camera box ThinkVisor that is used to control something like this object. So this object can be connected to a ThinkVisor. The user can add the virtual things that control this object in his silo and using his technology to move this stuff. This is an example of renting a drone, for instance, and so forth. And yeah, so finally, some final characteristic of our Cloud of Things. Inspired from NIST definition of cloud computing, our Cloud of Things offer is on-demand service. This means that a consumer can provision IoT resources like virtual things on IoT broker in an automatic way. Provide broad IoT access. This means that you can access the data using different technologies like NGSI, NGSLD, 1 and 2, and up to you. Has a broad support of IoT devices, so because it supports heterogeneous IoT sensor and actuators, because the interfacing rule is task of ThinkVisor, okay? And finally, it uses resource pooling because use underlining a pool of underlining computing and IoT resources. Some references, and so I have a demo, but actually I have no more time, I guess. And so you can see this video if you want to see a real demonstration of IoT in action through the shell, Kubernetes, and so forth. Thank you so much. Okay. Can I leave the session?
Thank you so much, Andrea. Yes. So I think that was all from Fed4IoT side, right?
Yes. Now we have some presentation about the use cases.
Okay, so would you like to take the floor and invite your colleagues?
Yes. So no, I haven't the agenda now, so I do not remind the sequence of presentation. If you remember the sequence of presentation, I can.
Sure, no problem. So what I have here is that we have use case 1, smart parking. So I will give the floor to Juan Andrés Sanchez from Odins.
Hi everyone, Juan Andrés from Odins. I'm going to share my screen.
Juan Andrés, you have to increase the volume of your microphone, please.
Sorry for that.
Okay.
Now better?
Yes, thanks.
Okay. Can you see it?
Yes, perfect.
Okay. Audience works on smart parking use case in Fed4IoT project. This pilot tries to deal with one of the most common issues of big cities, the traffic congestion. One of the main causes which contribute to this problem is the number of vehicles wandering around the city. The citizens try to find a parking spot in a certain area near their destination and can park their vehicles. In our Fed4IoT smart parking use case, the pilot is situated on Murcia city, which is located in the southeast of Spain and with a population of 450,000 citizens. Smart parking provides a solution that allows them to reduce the amount of time for car parking activity. In this sense, our pilot takes advantage of the Fed4IoT framework to provide a service that tracks the state of the parking spots and to provide the driver with this information beforehand. And with this, we get more fluid traffic in the center of the city. Focusing on the pilot design, we present the most relevant components of the pilot architecture. Smart parking solution integrates the information coming from the firewall-based MyMurcia platform. There are two main types of context source. The availability of private parking sites in terms of unoccupied parking spots and the probability to be able to park in the regulated parking zones. In this case, the data is obtained through a machine learning model trained based on the logged history of daily expended tickets. Availability information from the parking sites and regulated parking zone are integrated into Orion Context Broker through IDaaS and IoT agent. other additional information is stored too in this broker. For instance, the sectors of the city, policies, taxes, or the location of the spots. This Orion context broker contains the real things of our use case and offers this information in a NGSI format to the Fed4IoT framework. Fed4IoT provides theme visor for data virtualization and slicing, obtaining the virtual things, and a virtual silo that is included too inside this Fed4IoT framework. Finally, we can see on the top of the smart parking pilot application, which consumes the data offered by Fed4IoT framework. Here we can see all components we need to instantiate in the Fed4IoT pilot platform to have an operational smart parking pilot. These components are parking site theme visor, which obtains all the related parking site information, regulated parking zone theme visor, which obtains the analogous information, and finally, virtual silo, which receives all information from both theme visors. All these components are deployed in the edge node of Europe zone of Kubernetes. This theme visor obtains all the information from the mentioned Orion context broker of the Mimurgia platform using the subscription mechanism. When a theme visor receives the notification in NGSI format, it processes the payload and produces a neutral format payload NGSILD, which is sent to the MQTT broker in a specific virtual theme topic. After this, the virtual silo will receive the information because before it added virtual things of smart parking. Then a virtual silo controller module processes and converts the payload to NGSI form and to the NGSI format and store it in a local Orion context broker. This way, the virtual silo offers to the smart parking application an NGSI API to access to the data. As the final step of our presentation, we will see the smart parking application and how it works. Smart parking pilot application provides a graphical user interface which allows to the user to define the current location and the destination through a map-based web interface. The user can define too the parking duration, the destination time, and another user preference as maximum cost, maximum distance from the parking spot to destination, etc. Once the selection criteria are defined and push it, the search parking button, the smart parking application accesses to the virtual silo of Virot platform to obtain the filtered information. Finally, it makes complex reasoning to generate a recommendation about the best destination area or a spot where to park the vehicle. Once the recommendation is obtained, we can see related information of the result parking spot as the cost or the distance. And finally, the detailed routes to follow driving and working to arrive to the destination. That's all for smart parking use case. Thank you very much for your attention.
Thank you so much. Now I would like to give the floor to Kenji Kanai from Waseda University to present the use case 2 of Fed4IoT entitled Cross-Border Person Finder.
Hi, thank you for introduction. I think that everyone can see my slide and hear my voices. So, good morning and good afternoon, everyone. Thank you for this opportunity to talk with you today. So I'm Kenji Kanai from Waseda University, and I'm in charge of the implementations of this pilot, namely the cross-border person finder. So now I would like to introduce the pilot concept, the integration to Fed4IoT platform, and a few demonstration results. Okay, so this slide represents the concept of cross-border person finder And the cross-border person finder is the application that notifies geographic locations for the persons that you want to find or monitor. So we think that there are some use cases, such as to find the missing persons or to monitor the senior students, and also to ensure the tourist safety in the smart cities. So in this case, we assume that the pilot is to find a missing person, but we expect that the CBPF can be extended to various camera monitoring services. And there is one more thing that we consider in the pilot. The pilot mainly uses the surveillance cameras, which are installed in the cross-border smart cities, like EU sites and JP sites. So the pilot must comply the requirement of the privacy protection, such as the GDPR. And in this case, the captured image or processed data cannot be exchanged among the EU and the JP side without user consent. So here is a summary of the requirements of the CBPF regarding the image processing, the privacy protection, and the deployment. So literally, the CBPF needs a capability of the find a missing person. So the CBPF requires some image processing, such as human detection, the face detection, or face feature extraction, and also the face feature matching. So in order to provide such the image processing in the pilot, so we implemented the series of such image processing by adopting a monolithic architecture or the microservice architecture in order to enable to perform on the edge computing platform. So the next one is a privacy protection. And there are two security aspects, such as user consent and also the service authorization. So the user consent is to ensure that the person agrees to provide information, including his or her face features, and also the attributes. The service authorization is to ensure to protect the illegal access from the anonymous and also to prevent unexpected use of the information. So final one is deployment. The CBPF requires the easy, the fast, and the flexible deployment to the smart cities. So as I introduce the concept of the CBPF. So CBPF needs to handle the on-demand user request. So this means that the required processing corresponding to the user's on-demand request, such as please find the Kenji or please find the Hidenori. So this means that the required process, these requests will be generated on demand, and the system needs to handle this request without any modification of the application side. So this means that the system will be configured according to the user's request and the user's information, even if the system has already deployed. So in addition, the CBPF functionality, like image processing capability, needs to be deployed on the appropriate servers on the smart cities in order to prevent unnecessary data exchange between the edge and the cloud servers. And also this deployment control will contribute to suppression of the response time, thanks to the local production for the local consumption. So in order to satisfy this requirement, the Fed4IoT variant supports such demand. So right image shows the deployment strategy of CBPF on the Fed4IoT platform. So in the variant, there are two unique features, namely the ThinkVisors and the VSIOs. So ThinkVisor offers on-demand and effective deployment and the actuation capability. So it performs the required image processing, and these processing are composed on the Docker container. So by using the Kubernetes, the ThinkVisor can be easy to orchestrate on the EU and the JP appropriate computing nodes. And also the VSide offers the sync isolation from the users. Then the users will retrieve the required data by just accessing their own VSilos. So finally, I will demonstrate the one of the results of the pilot. So in the demonstration, we validate the deployment control capability of the Valued. So we deploy the pilots to the 5 EU and JP sites, Valued testbed. We deployed the Murcia, Grasse for the EU sites, and the Kumamoto, Hakusan, and Tokyo for the Japanese site. So these figures show examples of 2 response times in different deployment strategies. The upper one shows the response time between the sync devices and the camera size, and the bottom one shows the response time between the VSilos and applications. So from these results, we confirm that both response time can drastically suppressed in the Valued successfully deployed the appropriate computing nodes. Okay, so well, this ends my presentation, and thanks for the listening.
Thank you so much. Unfortunately, we have another Zoom meeting at F6S scheduled for 11 a.m. and I have other colleagues already on hold for this meeting. So since we are a few minutes delayed, I kindly ask the 2 presentations that we have on use case 3 and 4 to please have 1 2-minute presentation. I'm really sorry about this. So that we can manage to give the floor to the next Zoom meeting that we have scheduled. So the next one is use case 3, carpooling, with Giles Orazzi from AGM.
Okay, can you hear me?
Yes, you can.
And you should see also my screen now.
Indeed.
Okay, so I understand I'm trying to go very fast on this presentation. As you know, carpooling is a practice where people meet in one place and gather in the same vehicle to go to a common location. This helps to avoid CO2 emissions, and this practice is encouraged by local government. So they build, they build some parking specially dedicated to this practice. But they also need to get statistics about how these parkings are used, because they want to be sure that they are used for carpooling and not for other usages. So we need to count the number of cars, which kind of cars are going in and out, and how much time they stay. And in the same time, we want to preserve the user's privacy. So we don't want to put cameras which send images to the cloud, but only pseudonymize the events. So this was the issue, the problem to solve in our pilot. I'm going to go very fast on this. We have some edge processing which get the video stream and go to events. The events say a car is coming in or a car is going out. We've done so. Here you see the pipeline, the processing pipeline for the video stream, which which goes to the Valued cloud at the end. This is done on site. And we've done a device virtualization inside Valued. Inside Valued, you don't have a camera, but you only control an event generator, which says car going in, car going out. And finally, you have a virtual silo which deploys a Stelio NGSILD broker, which is the one implemented by EGM. And we have a dashboard which shows some useful statistics. On the silo side, we have some algorithms to associate entry and exit events. We also have to build the dashboard data and to serve them to the website. I don't go through this NGSILD model, but don't be afraid. But just to say that we try to do as much as possible things with NGS-ILD, since Fed4IoT was very active in the standardization of this NGS-ILD format. And we also used as much as possible the queries which are standardized in the NGS-ILD standard. Yeah, some images of the deployment. You see the camera which is on site, the box where the edge processing capabilities are installed. And you can see here and there some images taken by the camera. The upper one is an entry event with license plates detected. And this is an exit event with the same license plate detected. At the end, we get an application which counts the number of cars going in and out, the number of cars which effectively stays for, say, more than 2 hours, the number of cars which stay a lot of time, in this case, it's more than 48 hours. And we have a mean duration mean stay duration on the parking for vehicles, and also what CO2 emissions are avoided by this carpooling practice in this parking. And you also see some cool graphics with entries and exit hours and occupation of parking. And that's all for me. I hope to have not taken too much time.
Thank you so much. And now I gave the floor to use case 4, wildlife monitoring, with Tetsuya Yokotani from KIT.
Hi. Okay, so my name is Tetsuya Yokotani of Kansai Institute of Technology. So today I talk about use case 4, wildlife monitoring. So, sorry. The objectives of wildlife monitoring are protection of social life, social life from the wildlife. So damage to farm by wildlife and attack to person by wildlife. This is a common serious problem in the local cities. So we try to promote the initial trial in Haksan Mountain area using various architectures. The Haksan Mountain area is located at here in Japan. So these photos show the overview of this area. In these areas, we provide 2 functions based on the various architecture, such as the detection of capturing wildlife and notification of approaching wildlife. So this slide shows the sync visor for wildlife monitoring in various architectures. In root data domain consists of the real things and the various devices, including some sensors and gateway. The gateway collects the data from these devices and unify to the interface to sync visor. In sync visor, the following functions are provided: the analysis of the several data collected by real things and providing service to be siloed via MQTT HTTP service mesh, including the general info, type of wildlife, direction of wildlife, and video of captured wildlife. So this is a sample of data from the sync visor to MQTT service mesh, the general information and index of video of the captured wildlife. This is a benchmark test. The latency is here. The average is 0.7 second. The 90% confidence interval from 0.56 to 0.85. So it is concludes that the latency is less than the 1 second. This is the accuracy. The capturing wildlife sees this graph, and approaching the notification the 100%. So finally, anyway, today we don't have much time. So this is finally. So please come to Hakusan mountain areas after termination of COVID-19. It is beautiful local city in Japan. Before your trip, we will remove all the wildlife. Thank you. Thank you very much.
Thank you so much, Tetsuya. And now to finalize, I would like just to give the floor to Keiko Doguchi from NTTE, which is the Japanese coordinator of MSec, and also afterwards to Andrea Detti, the European coordinator of Fed4IoT, just to say the final words before we close our final M-Sec and Fed4IoT joint webinar.
Hi, thank you, Nadine. I think you can hear me.
Yes, we can.
Okay. So thank you. Also, thank you to Fed4IoT members for this collaboration opportunity. I'm Keiko Doguchi from NTT East. We are the coordinator of MSec project on Japanese side. So MSec project is gonna be end after 3 years and 3 months research activities. Unfortunately, there were many restrictions because of this pandemic situation. Meetings between project members were restricted and communication was only online. After all, some members of MSec project has never met face-to-face. However, all the partners are very great and great collaboration we had made. I really appreciate for all your work and efforts. I hope our project results will be utilized in real world in the near future, and it'll be great if we can do a reunion session or something when the pandemic is over. Thank you very much for all great work.
Thank you so much, Keiko. I now give the floor to Andrea.
So I want to say thank you to MSec project again to have organized this meeting. Also, the Fed4IoT project is finishing just this month, and personally, I think that we have had a very good collaboration with all colleagues, European, Japanese, no matter. We have good collaboration. We are a single team, and also from let's say, how to say, human point of view, exchange the way how our people live, it's good. And unfortunately, for pandemic problem, we haven't had many occasions to meet. Some occasion, however, we had. And besides, let's say, the fact that I hope that our technology will be used in the future and can increase the competitiveness of European and Japanese company. I hope that there will be novel opportunities for a EU-Japan collaboration that I don't know why, but I haven't seen in the current program. But I have to look it better, definitely. And so I would like to thanks again our Fed4IoT partners, colleagues, and let me say friends that work in this Cloud of Things project. Thank you.
Thank you so much, Andrea, and thank you so much to all of you who participated today. I hope that you enjoyed our joint webinar, learned more about the M-Sec and Fed4IoT projects that are going to end tomorrow after many years of good collaboration between the EU and Japan. So wish you all a wonderful day or afternoon if you are in Japan, and hope to see you again in a future webinar. Thank you so much. Have a wonderful day.
Thank you
so much.
Thank you.